So far, we have studied many decisions: lead time, sourcing, inventory, replenishment, markdowns. Now step back and ask the deeper question behind all of them. Why can companies have everything at once? That's what trade-offs explain. So far, we have studied many decisions: lead time, sourcing, inventory, replenishment, markdowns. Now step back and ask a deeper question behind all of them. Why can companies have everything at once? That's what trade offs explain. The temptation is obvious. What if a company could be fast, cheap, flexible, reliable, and offer high variety all at once? That sounds ideal, but real supply chains do not work that way because every advantage comes at a cost. This is the core idea. A trade off exists when improving one performance dimension requires sacrificing another. That's not a failure, it's a structural reality because resources are limited. You cannot be everything, you don't have money for everything. Time is limited, capacity is limited, our supplier capacity is limited, transportation is limited, capital is limited. There are so many things that are limited. So design becomes prioritization. What do you want? What do you prefer? If you have to choose, what is a priority for you? Take the first major trade off: speed versus cost. If a company wants more speed, wants to be fast, wants to react fast to changes in demand, to what consumers want, it often needs flexible capacity, being able to change their capacity, the production planning, premium transportation, be faster in moving the products, moving the raw material. They can't lose time. They have to be quick. Local sourcing, not have sourcing very far away because distance creates increases time, and smaller batches, so they don't make too much because they want to see what the market is going to how the market is going to react to their products, so they can make more or change them. Of that, of course, raises costs. It's not cheap. It's more expensive to do all this, right? So speed is possible, but it's not free. And a good example is Zara. We know Zara is a good speed over cost example because they explicitly link rapid trend reaction to flexibility and proximity sourcing. Now look at the other side. What if the company wants lower cost? A company that wants lower cost has to rely on scale economies, producing in large quantities so they can use resources better and in larger amounts of products, so they can reduce the unitary cost by distributing all the cost to more products. They need standardized processes that don't change much, because every time a process must be changed, then we have to stop the process, people have to stop work, they have to set up machines. So that's time in the process, not making products. It's time in the process just to adjust the process. And if efficient scheduling, because you have to receive the raw material, not have the material too much time in inventory, and then put them for production, and then after that having the transportation right. So that's efficient scheduling. But all this is lower response to the market. So that's reducing responsiveness to changes in what consumers want. This type of company cannot keep changing, like during the season, or waiting to see what's going to happen, if consumers are going to like or not. And a good example is H&M. H&M is an example of efficiency over flexibility, because they say they pair a best price promise with a large external supplier base rather than a tightly controlled artisanal network. Now the next trade-off, flexibility versus efficiency. Flexible systems can adapt when demand changes. So during the season, consumers don't like the product, you can go back to your design process, redesign the the clothes, cut them, sew them, send them to the stores. That's flexibility. But flexibility requires unused room. You have to have time to change things. You have to have some buffering capacity, extra capacity to be able to redesign like some of your clothes, or maybe tell your suppliers to send again a new batch of fabric. That's unused room. So you are paying but not using. Smaller runs, so you don't make like 10,000 units, you make 500 units and see how the market responds before making more. And that's good, because if you're not selling um, fewer quantities, not larger quantities. Faster changeovers, remember what I mentioned, like if you have to redesign and be flexible, you have to change over things more often, but you are faster in doing that, right? You need to be. That means lower utilization. You are changing more your equipment, you're changing more your processes, you are waiting something to happen, and you're not using your capacity at full scale. But that's in purpose, because you don't want to be a mass scale company. So adaptability and efficiency compete with each other. Variety is another example. We have a trade-off between variety and complexity. Offering more products may attract more customers, because um, you can satisfy different needs. If you have variety, maybe if the customer doesn't need this one, then you have another one to satisfy the customer's needs, and then you can satisfy different populations of customers. But each extra product adds complexity, right? It raises forecasting difficulty. To whom you're going to forecast to? With so much variety, then you have to have different forecasting models, different forecasting data, then forecast for all these different types of customers and products. That becomes harder. Raises scheduling also becomes harder. You have to schedule in a way that you can do different products. You cannot wait like a month to make the other product. If you're doing variety, you have to do variety within the same week. Like Monday and Tuesday, you're gonna do one, Wednesday, you're gonna do another one, and Thursday and Friday, another product. So variety is gonna add complexity to scheduling. To do all these different types of products, you need different fabric. Then you have more like complexity when this fabric's coming to match when they're going to be produced. That's scheduling complexity. Also, inventory management becomes harder. Like I just mentioned to you, you're gonna make different types of products, you're gonna have different types of fabric, different types of accessories and other parts. Then you have to have multiple small inventories or bigger inventories of all these different types of products. So inventory becomes more difficult. Um, so variety creates appeal. It's nice to have variety, but also creates operational burden. Now think about demand spikes or disruptions. Imagine that you have the store, you put your products for sale, and now many customers want to buy them. You have a spike in the demand, or you have a disruption. Maybe something happened, and maybe one of your suppliers had a problem, an operational problem, and cannot deliver the parts for you. That's a disruption. How does a company respond if everything is already fully loaded? It needs extra room, unused capacity, extra labor, overtime, backup suppliers. All these are capacity buffers. This extra capacity, like having people or your employees can work extra time, or your suppliers can send more like fabric to you if you need, or if they are sewing all the product, the clothes for you, they can sew I don't know how to say this one, is very sewing all these clothes for you, right? So that's capacity buffer, and that's very important if demand spikes, okay? Or if you have a disruption, maybe you need like a supplier that can back up you if the other supplier cannot send what you need. But buffers have a price, which leads us to the universal rule. There's no perfect configuration. No system can maximize speed, minimize cost, maximize flexibility, offer maximum variety, and remain perfectly stable all at once. So the idea of best has to be redefined. Best means fit, not total maximization. No free lunch, right? This leads to the universal rule. There is no perfect configuration. No system can maximize speed, minimize cost, maximize flexibility, offer maximum variety, and remain perfectly stable all at once. So the idea of best has to be redefined. Best means fit, not total maximization. So what strong firms do? Strong firms are not the ones that avoid trade-offs. They don't try to avoid them. They are the ones that make them consistently, right? Fast response firms choose speed over cost. They know they can be good at cost as well. So they of course design their operations to reduce the cost, but cost is not a priority. The speed is a priority. It's gonna come at a cost. That's it. Let's do it. But let's be fast. Cost efficiency firms choose efficiency over flexibility. They take for granted that they cannot offer flexibility. They're not aiming for that. They're aiming for being efficient, reduce cost, maximize like capacity utilization. So in order to achieve that cost reduction. Luxury firms choose exclusivity over volume. They don't try to, again, maximize capacity. They are concerned about exclusivity, the prestige, the rarity, the scarcity. Reliability firms choose stability over variety. They offer the basics. They're not going to come up with something fancy or trendy or something that is new, or they prefer to play the basics, and that's it. They're going to offer the basic colors because that's what the promise is. So consistency what makes the system coherent. These companies, when they make the decision about what promise they want to make and what they want to deliver, they are consistent with this promise. And all the choices, all the operational choices, tactical and structural choices, they are consistent with one another. And the more consistent they are with one another and aligned with the promise, more likely the company will be. One example here we have is Uniqlo, which is a good consistency example, because again, I'm going to refer to their lifewear concept that stays centered on simple, high quality everyday clothing rather than chasing multiple conflicting promises. They try to avoid put themselves into conflicting um, promises, conflicting operational decisions. What weak firms do? Weak systems often send mixed signals to the market and consumers. For example, a fast promise with a slow structure. A company promising access to trendy products but outsourcing their production to Asian countries and shipping them via ships through the ocean, which takes a month to get to America. That's a slow structure. A low price promise with an expensive system. Nowadays is the opposite. Imagine a low price promise, but producing locally in the US with an expensive labor cost, or in smaller batches, not having the benefits of economies of scale. That's a low price promise with an expensive system, or a high variety offer, like a company offering high variety but no tolerance for complexity. And then you want to have like different products, different types of products, but then you cannot accommodate their production within the same week. Scheduling becomes too complex that they can't do that. That's conflicting. So that's where internal conflict begins, and that's where performance usually breaks down. Trying to do something that trying to achieve a performance that your system is not designed to deliver. So here's the decision test. Whenever you look at an operational choice, ask three questions. What improves? What is sacrificed? And does this trade-off fit the promise? Remember our question? Does that trade-off fit the promise? If the answer is yes, the choice may be strategically sound. If not, the system is drifting. The core meaning of strategy, and this is the deepest point of the lecture, strategy is not just choosing what you want. It is choosing which costs you are willing to accept in order to get it. This is what trade-offs reveal. They reveal operational identity. So here's the final idea. Trade-offs do not weaken strategy. They define it. The question is never whether trade-offs exist. The question is whether the company is making the right ones for the promise it wants to deliver. In the next lecture, we compare different fashion models directly. Because once trade-offs are clear, the next step is comparison. How do different systems choose different costs to accept?